on, guys. Smith did this song for me. Like no fancy shop, just as iron and fire. Dreams wired up with quiet desire. Each amp a beast, a story told by hands that build, not hands that fold. Going on, Adam. Going on, Charles. Thank you. Opening with this song, I'm playing the entire song. It's such a good song. Stick around, it's going to be a pretty good show. All right. Pause that for a minute. So what's happening? It's Sunday Fun Day. Yes, we are in May. It's been a minute since I made a video, and I do apologize for that, but a lot going on. And we have a lot going on in our big old world we live in, and it makes things difficult from time to time, but we're still trying to press on. And as you guys seen this a build a while ago, believe it or not, I'm actually ahead of schedule because I started this unit before I went to Louisiana. And then I got it pretty much in a shape where I come back and I had to deal with putting the rest of the way together. But the guy, he was patience of an angel. So he gave me a free run on this one, and I laid into it, and I put some big stuff in this one, and put a lot of care, a lot of thought, a lot of redesign work went into this unit. So this is a number one, as I marked it. So, made some pretty good size changes. In the past, I used to run 4 2-gauge wires in the back end of this thing. Now I'm running 2 2-aught cables. And I have very, very large ferrite on each one of those cables. And it fits nicely in there. So, as you see these bus systems, and the way I build mine is unlike any other that you guys probably ever seen. You've seen guys probably try to do similar things to how I do the bus, and it takes a little bit of effort, a little bit of work, and quite a bit of money. Because these split bolts, these burgundy bolts, are not exactly cheap. You can see the size of my finger. So, and that is rather large ferrite on there as well. That is a large zip tie. So, just to give you an idea of the ferrite size, these are 1/2 inch. These are much larger. So, made some changes there, made some other changes, and things that just makes me want to think a little bit more on how I'm putting something together and how I'm assembling it. Over the years, what do we see? And these are probably some of the things that I changed because I've seen lots of damage because of the things that I've changed. Now, if you guys ever notice, I carry my 100 ohm resistor over my combiner quite a bit. I'm going to put my finger in there, because when that lights up and you have that thing hugging that ferrite right there, that gets bloody hot. So hot I've actually seen it crack a combiner ferrite. So what purpose, what advantage would you have if you lowered this and put it right across the top? Man, there's no advantages at all. You got air, you can breathe, okay. You can see it all the way around. The other thing was, over the years, I've noticed, and it's kind of a more pain in the butt to do the work, but as you can see, my 10 ohm resistors are no longer on the board. Why? Because sometimes the 10 ohm resistor could burn on the bottom. You couldn't even see it. But ultimately, again, it's a flash fire. When a 10 ohm resistor goes up in smoke, it burns the side cap that's here, the 103 or the 104. It burns the board, and it just makes a big mess. It's a small fire. So if you're living in a big city and you have houses corner to corner, side by side, within 4 feet, your neighbor's house burns, you're going to take damage, and this is no different. So any way you want to cut it, great looking amplifier. Turned out really nice. Black and pink. 2-watt cable. Remote jack in the back. 2 grounds on here. And I suggest you use both of them, with a minimum of 2-aught cable feeding your grounds. Your ground should be the same or equivalent size of the size of your B plus wire. You have 2 of them, you should probably put 2 of them on there. The other thing I've been doing a lot recently is, after working on amplifiers over the years and going back, even my own, I go back and I tear something apart and I look at the corrosion buildup on here. Now you have 4 points of ground right here, and these are 2 major ones on the left and right. But you have your SOs. They need to be grounded too. Even though they're hooked up to this chassis, it don't mean they don't need more ground. If you lose ground, you lose coaxial ground, you lose equipment. But the oxidation is what I'm talking about here. And I put OxGuard grease all over my strap on the chassis, and I put it all together. And then it sandwiches out, and I wipe off a lot of the extra, but you can kind of still see some of the gray grease back there hidden around the washer. It's not going to corrode, especially I send a lot of boxes out to California. A lot of boxes go to Hawaii, and it's a high salt in the air. Hell, I'm in New Jersey, a lot of salt in the air. So if you're not using anti-seize or anti-corrosive grease on your equipment, on the bonding parts of your equipment, even if you're in your house, you should probably put a little bit. A little bit goes a long ways with that stuff. What's up, Sean? How are you? What's up, Glenn 1600? Nobody's business up in Alaska. So as I preach and continue to tell you guys all these little things that'll help your system survive brutal winters and harsh summers, if you simply just go and do the maintenance, make sure your coaxes are phased properly, everything will take and come into play. Yes, I'm on a dummy load. My dummy load can take and handle this equipment just like your antenna should, and your coax feeding it. You have to be able to take and have a system that's going to be able to handle what you're putting into it. So if you had an 8-pill and you're upgrading to a 32, I highly suggest you should probably look at your upgrades on your antenna system, your coaxial system, etc. Power supply, power management, meaning the power cords, power ground, and power cable. All of those things come, it's essential that you have it correct. And if you don't do, and you make shortcuts, you're not going to see the performance. Well, I'm going to tap out on performance tonight because I'm stuck at 15.5 volts or so. But that's a realistic number. I mean, most of the guys that are getting these lithiums, they can charge all the way up to 8 to 16 volts. I suggest highly don't go over 16 volts, even though you have the pad of 0.2 of a volt. Guess what? If your voltmeter's messed up, probably a little bit more pad there, but I wouldn't want to push it. I wouldn't want to be in the vehicle or in the house or garage that has a lithium fire. It's not cool. But any way you want to slice it or dice it, you guys got to take and have your system right to run equipment, especially of this size. I've had many offers, and many people ask me, build a 48, build a 64. No. Y'all go get an AC box after that. A 32 is pretty much it. You're tapping out. Hey guys, oh, I got a 48, I got a 64. Do you really hear them over the air? Oh, I build them all the time with HGs. I never heard one on the air. Not for long if I did. So the 48s and 64s have never been on my list for a long time because I had a failure. It's a 32 pill. It was a 64, but Goliath is still here, over there, hidden. And that was a 48 failure. So to be able to take and understand that you failed, could I go forward today knowing I have more knowledge of the parts? I probably could, but I'd rather not. It's bad enough, it's costly enough when someone breaks a big school bus or a 32 pill. It's costly enough, even to repill it. You only get maybe like 2 strikes. If you blow a box 3 times, man, you dig it in your wallet. It's time to repill it. Some people believe that. Some people don't. I've ran boxes, my own personal boxes, to the raggedy edge, broke them terribly, and then turned around and picked up and understood what I did to it and what it took to break it. So you guys want to run your stuff super ridiculously hard, you can. I'm going to show you guys, the peeker tweakers are going to love this video because I'm going to show them, as I have been showing them, Psycho Zip. This is a little driver. You've already seen that guy run this box. It's a match driver for it. I'm going to run this all the way down, but you're going to see those peak numbers are still going to be right up there to the same point of when I max this box out in RMS drive. So let me take and get a few things going, and then I will take and start this show. Yeah, I did that song. I got a couple of them. All right, so here we go. Let's get the lid down on this thing right quick. Real quick. Let's just take a view of it. All right, there you go. 2879Cs. Good looking box. Huge back end on this thing. 30 kV back end. Then all the fans are 106 CFM filtration system on it for the voltage and the air. So there you go. Let's throw the lid on it. Get her going. Alright guys, here we go. We're going to light this thing up. Let's look over the slugs real quick. So Jeffrey Clark, we're going to look at a 1000 watt slug on the input drive and a 25 watt slug going back to my driver. Alright, over here. We are going to look at a 5000 watt slug, a 10,000 watt slug on the digital, and then we're going to look at a 5000 watt slug and a 10,000 watt slug on the analog. There is the bench. Nothing really fancy, just a bunch of tools. That's how I look at it. Expensive voltmeters. they are. Alright, so probably should set a carrier. I don't think I did that. That'll work. Okay. Alright, here we go. We're gonna, where do we want to start? Now let's look at working drive. Audio, 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 audio. That's a 1,000 watt slug. Each line's 20 watts. And yes, you heard the fan speed up a bit. I have a lot of RF in this room because of this thing. Everything's on top of each other here. 1,000 watt bottom slug. Each one is 20 watts a line. Audio, 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 audio. So about 320, maybe 330. All right. Before I move on any farther, real quick, phase angle coming from my radio down to Zippy is a half a wavelength. From Zippy to the 32 is a quarter of a wavelength. Whatever coax you decide to use, make sure you can ground it really good and it's fully functioning. Cut the frequency and you'll be good to go. At a quarter wavelength between the driver and the 32. A half wavelength from the radio to the driver. Out of the 32, normally you'd run 12 or a half a wavelength. And if you do that and you have line sections on the wall, which is fine, incorporate that line when you tune your antenna because it's going to change everything if you start adding line sections, okay? So, got that out of the way. Let's see some watts. We can make them. Look at my inputs real quick. We are at 330 or so a drive input, 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 input. About 2, audio 2 watts. Alright, here's your voltage. Audio voltage, audio, 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 15.6, and here is my amperage. Audio, 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 audio. Hey, 430 amps there. Alright, let's take a peek and tweak. Let's take a look at this 5,000 watt analog. Here you go, 5,000 watt analog. Bottom scale, each line is 100 watts. Audio, audio. It looks like about 2,500. Let's look at 10 kilowatt slug. Bottom scale, each line is 200 watts. Audio, audio, audio. So 3,000, 3,200. Let's look at the peaker tweaker. Peaker tweaker 10,000. Audio, peaker tweaker, tweaker, peaker, tweaker, tweaker, peaker, tweaker. Almost 5,900. 6,000. And here's RMS on a 10. Audio, 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 audio. 2.8 to 3,000. Let's look at the peaker tweaker, tweaker, peaker, tweaker, peaker, tweaker, peaker. 6.2 kilowatts. I'm cool with 6.2 kilowatts. I was only hitting it with 300 watts of drive. So think about what I just did. Let's take a moment. Alright, let's take 330 watts and times that by, I take that back, divide that by 32. I'm only driving this box at 10.3125 watts per transistor right now. I don't even know it's running. Now, I'll tell you up front, you get up around the 25 watts per pill range, you're going to teeter-totter between success and failure, depending on how terrible your, thank you Adam, how terrible your reflection is and your coax and all the rest of the bad things that you guys have bad habits with. I have them too. I try to fix them. I truly do. But, you know, we're at 15 watts. How'd you go with 15, Adam? I got 10. You got 15. Look at that again. 330 divided by 32. I got 10.31. Anyway, regardless, sidetrackers. That's only 15 watts a pill. It's not a whole lot. Now that we'll cut it off, we'll take a peek. Audio 1 2 1 2. Yeah, we hit 330. All right, so let's just, that was zippy all the way down. Let's go about halfway up. See what that. Yeah, 1 2 1 2. Alright, so we picked up like 100 watts or a little better. Gonna get a carrier on this thing. That's cool. Alright. Let's use our working drive. Audio, 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 audio. 480 watts working drive. Input reflection, 25 watts. Each line's a half. Oh, you're suggesting 15. Alright, very good. Audio, 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 audio. Nah, hey, guess what? That just went down. It was at 2, now it's dropped. Yeah, I'm splitting hairs, but guess what? It moved. It moved a better direction, downward. Alright, same 5 kilowatt analog. Audio, 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 audio. So there's a good solid 3,500 on that. Let's look at the 10 kilowatt. Each line's 200, bomb scale. Audio, audio, audio. Coming in nice 4,000. And let's look at the digital. 10. Audio, audio, audio. 39. I'm happy with that. They're coexisting. Let's look at the peaker tweaker. 67. Peaker tweaker, tweaker, tweaker. Audio, audio, audio. 1, 2, 3, 4. 65 to 67. See, so how do I want to say this? I only increased 100 watts on that. I was doing 330, well, a little over 100, 180 watts increase, about 200 round up. Anyhow, you got it. I increased my power on my RMS, and the peak did go up. Now, you're going to see this peak just kind of plateau. It's just going to, I ain't got any more. Why don't I have any more? Because I don't have any more damn voltage. That's the problem. See, look at my amperage now. Audio amperage, audio, 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 audio. Alright, we're cruising at 500 amps. That's obtainable. That is very obtainable in vehicles. 2 alternators and a really good lithium, you can do it all day long. You could probably get away with one really good 400 amp alternator and a really good lithium. And you can probably run this junk. So, and you can pick your poison on your voltage all the way up to 16 as far as that matter goes. So, boy oh boy, what can we do now? We're doing about 500. Alright, let's just go where we were just talking about. Where we're hanging out. Let's look at this. We're not going to see that much more increase in peak. And probably not a whole lot more in RMS. Why? Because this is getting sagged. It's just getting hit. I don't have any more volts. I can't make any more watts. So let's look at this 1,000 watt slug with the drive not working, meaning it's driving the unit. It's bypassing right now. It's not working. So I'm going to lose a few watts just in the circuit, which is minute. But here you go. Audio, 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 audio. So 580 to 600 watts RMS is the drive level I'm fitting to go into this. So let's just call it this one. Let's look at 600 watts now, and we're going to take and divide that one into 32. Now I'm still very safe. I'm only at 18.75 watts per transistor of drive. Kind of, this is all I have left in my bench. Now if I decide to take and go bigger and do another power supply and make more voltage, and it's not worth it for what, another volt? Man, y'all can use your imaginations or the calculator or your own truck or your own stuff. This is a very good common test on what I'm doing. And it's still all being ran really safe, so you can't say, oh, he's driving the holy heck out of that box before the customer even gets it. No, I'm not. I'm doing the math. The math tells me I'm safe. Alright. Let's get this thing a-singing. And we're going to look at, well, I'm just going to leave that right in peak. I'm going to leave that right there. I'm going to leave that in peak. All right, let's look at my working drive, input, amps, all that stuff. Here we go. Actually, let's look at the volts first. Audio, audio, 15.5. Let's look at the amps. Audio, audio, 562 amps. Write those numbers down, somebody. Here's your input drive level. Audio, audio. I lost a little bit. I lost about 20 watts there. Input reflection, because it's working in the circuit. The circuit sucks it up. Audio, audio, audio. 1.5. Gotta love it. 5 kilowatt slug. And know it's not going to go in the corner. Audio, audio. Alright, good solid 4,000 there. 10,000 watts RMS. Audio, audio. 44 there. There's the peak. I ain't going to change it yet. Audio, audio. 6.8. And here's your RMS. Audio, audio. 42, 44. I think she's running pretty doggone good. I definitely ain't got complaints about it. Now, has anybody got any questions? Let me ask that. Let's see here. Do we have any questions? Anybody want to type in here? I don't even know how many people I got up in here right now. I can't see that part of the interweb. I don't know if you guys got any questions or not. But if you do, go ahead and type them in. I'm going to take the lid off this. She just looks as pretty as can be. Take a little temperature check. 90 degrees. 91. No, I didn't bump it a lot of times, but still 91 degrees. Yeah, she's running nice and cool. Okay. Anybody got any questions? How are you grounding your bench? Good question. I do have that. There's a good song for this. Listen to the words. Here's my ground. 3/4 inch pipe, carriage bolts, 5/16. This goes outside into a stake in the yard. Right out the window. That's how I'm grounding my bench. These straps go to these power supplies. This all is just a junction point. And meters everywhere. A voltmeter for the big supply right here. Voltage up here for the radio. And that's the voltage for this power supply up here. That's just a driver there. There's a 3-pill and a 5 in one unit. 100 amp power supply in the lower deck. Thanks, Charles. I really appreciate that, man. What would you give you? What would it? All right. So the question is, what would this unit do at 200 watts drive? Okay, we can do some live drive tests. Give me a second. Put a lid on. Now I'm trying to think of how I'm going to make 200 watts. I guess we'll find it, huh? Let's start backing stuff off. That's kind of a fun little song I put together. I guess I can go in there and alter them. I hadn't did that yet. These were done in one cut. One cut. One cut. One cut. All right. Let's see if we can make 200 watts. Let's see. Audio, audio. Hey, you might be in luck there, buddy. Get my glasses on so I can see what the hell I'm looking at. What's going on, 6-shooter? All right. Alright, there we go. Let's see if we can make 200 watts. Audio, audio, audio. That's close. That's about as close as I can get it because I can't get my radio down any lower in my voltage. And this is backed all the way down. So, I'm sorry. I'm just making too much damn power for you. Alright, let's set a key. Let's set a carrier on this real quick. Alright, here's 200 watts. A little audio on it. Let's see the drive. Audio. Yeah. I'm about 240, 250. Sorry, I can't make 200. 5 kilowatt slug, bottom scale, each line is 100. Audio. 2,000, 2,200. So guess what? That's about times 10, wouldn't you think? Let's look at the picker tweaker. Breaker, 6,000. See the picker tweaker up here on this tent. Hey, tweaker. 6,000, 58. 200 watts. Talk about loafing a dog. Wow. Alright, let's see. Let me try to scroll backwards, see if I miss anything here. So Trevor, hopefully that answered your question. How you grounded a bench? Donald, I think I answered yours. 19, I don't know. Breaker 19. Well, 76 up in here. 0711. Alright. The box would last a lifetime at that rate. Yeah, actually you could go as high as the voltage as you wanted to on that drive level. We can put that thing at 17, 18 volts probably and talk skip on the dang thing. A little bit of drive. Well, it's kind of like what they do on the 4CX series tubes. Yeah, I make a race car and daily driver. Thank you, Steve. Appreciate it. TJ Bell, what's up? Nice work. Thank you, sir. Jay Austin, good morning, good afternoon time to you, all the way down to Kangaroo Village, Australia. You know, I got my 808 up in here. I always get the 808 guys. The 808, I appreciate you guys so much. You don't even understand. That's why I try to make it out there every year. And that flight is just getting worse and worse every year. I think I'm just losing patience. I don't know. But I do know this. I built some pretty nice little units here. I'm not going to take the lid off the driver. We'd already took a look at that one. But it's the equipment that I built. Yeah, I take my time. I'm not in a race. I'm not that guy, man. Hurry up and get my paper route done so I can go screw off. I'll take, I'll work on this stuff a little bit at a time, and I won't take and spend 7-8 hours sitting still. I can't do it anymore. So I'll work for a few hours and walk away for a bit, come back. I do portions at this part. Kind of like eating. Eat too much, you're going to be full and you ain't going to be able to move. Well, same thing. You sit in a chair too long, you ain't going to be able to move. But like I said, guys, I've really made quite a few changes in these for the better. And I really like the design. I'm going to keep it until I come up with I have to make a change. But I have a lot of filter on the board on the B+. A lot of filter on there. These circuits have changed. They're loading differently than how they did 2 years ago. For sure. Totally. 3 years ago. They're loading different. They're loading different. These 24s are loading different than the 22s. I think it all falls down to what one person is looking for. And I look for every ounce I can get. I could literally take and change parts in this box and detune it because I put the wrong values in. And that's how you have to learn. You have to take and spend your time on that bench, on that practice board, and see, not just with the batch you did a year or two ago, we're talking recent stuff. So if you're not looking, you're not overturning every little pebble and rock to find the power, either you just don't care and you're just chasing some dollars, or you truly are building an amplifier and not a linear amplifier on frequency. This is as close to frequency I'm be able to get on these things. And every time I make a change and I see increases, that tells me I'm more and more on the frequency. And that peak meter's telling me how efficient that I'm actually getting out of these amplifiers by taking and utilizing my tools, my voltage, my amperage. You take that voltage and amperage and then take that peak, and now you got something to compare it to. And if you don't do that, you're a fool. I used to never show peak because it was a relative to me to show you guys the peak. It was a relative. That's something that I used for when I designed it or I worked with it. The peak, when you hit the right frequencies, the peak normally follows what's going to go. For years, I didn't do the peak. I didn't even show the peak. I had a meter, didn't bother pulling it up for you guys, just because there was no purpose behind it. Unless you really want to know how efficient your amplifier is running. If you're taking and feeding your peak kit every week for new 9-volt batteries or rechargeables, whatever you're putting in them, just to see that flash number, so what? It's really not a big deal. The most important numbers are your reflection, your input reflection, your output reflection on your antenna. Those are very, very important. In the input reflection, it's not going to change. So once you find the coax, it's either going to be a half a wavelength or it's going to be a quarter of a wavelength between whichever driver you're using. You have to check it. Even though I say you need to take, I only have one line section, you need to take it off of here and move it over to here, because everything you did, you set your carrier level and you say audio, and that's where it ends. That's not going to change unless you go up in here and you turn something before you take and make this change. Once you know that system set, just move your line section over, get a small slug and feed it back to that driver, and now you can take and read what the communications is between A and B. And you only have to do it once. You don't have to leave it in there permanently. You just need to know, does it want a quarter wavelength or a half a wavelength? That's all that test is for. After that, you can pull the meter out, put it back where it's at, and you're good. You don't have to go and monitor your inputs all the time, especially if you're a guy that's going to run it efficiently. This guy here is probably going to run it right here. I'll tell you right now, I know this guy. He's probably going to run that driver right there. Even though he can go up here, he's probably going to be here or here. He's going to loaf it. I know him. I know what he's going to do with it. And that's nothing wrong with it, because it's not going to make any difference in DX if you pick up 500 watts or 1,000. You're really not going to make that much of a difference. Now, if you can take and increase 5,000 watts, now you're going to make a difference in DX. But if you don't have conditions, even if you got 10,000 increase, if you don't have conditions, you're not talking skip. That's all there is to it. So you can't will the skip to come in and force it and say, well, I got so much power, I can make conditions whenever I want. Well, I used to hear those old guys when they're sitting there drinking a beer. Cheers to the old guys that passed. They told me lies and 99s that you would not believe. Yeah. And after I went out in the world and I learned and I taught myself a lot of things and asked a lot of questions to a lot of really smart people, here I am today. Now I'm trying to tell you guys to do it right from the first time. I don't give you a wrong answer, at least I definitely try not to. That's a fact. Well, hey, where's Molly at? I hadn't seen Molly. Where's she at? She ain't even popped out all video. There she is. What you got going on, Molly? How are you? How's things? You good? What's going on? How are you? You were napping, huh? Yeah? What's going on? You gonna say hi to everybody? Molly? You gonna wave? What? You just woke up. Give me a wave. Give me a wave. Good girl. Yes, you're a good girl. Yeah. Yucky eyeballs. Yes, you're a good girl. What's up? What's cracking? Molly, what you think? We got a Mozilla to build. We have an 8-pill to build here in a little bit. Yeah, we have an 8 to do. It's a Mozilla. It's one of yours. Yes, I think it's gonna be red and black. Yeah? What do you think? What's up? You gonna talk? You gonna say hello? 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 Say hi? Say hello? What's happening? What'd you do all weekend? Did you hang out with the babies? You don't look like you feel too good. You okay? What's up? You're kind of boring. All right, we're gonna say goodbye. Bye-bye. Yeah? Okay. All right. Then what? Kitty? Yeah? Hey, sit. Gonna wave bye-bye to everybody. Hey, sit. Gonna wave bye-bye? Molly? Bye? Wave. See ya. See you later, alligator. All right, just say it. Goodbye. All right. All right, guys. Well, hey, thanks for hanging out to the end. You got Leo's attention. Leo's up in here. You gonna say hi to him? Say, what's up, little man? Say hi, Leo. Yeah? Uh-huh. What's up? Hey, last time you saw him, you didn't even hardly want anything to do with him. Huh? Because you got other boyfriends now, don't you? You're a hussy. Well, there you have it. Another school bus in the books. Happy she's done it. I took my time, and I'm really, really proud of it. There you have it. Turned out well. All right, guys, there you go. A little zippy. Sliding out here. Take care. God bless. Thank you very much. To the left.